Unless you look very carefully, this just looks like a rotating cube. Especially when viewed from an angle, we automatically attribute to perspective the frame's apparent varying shape as it rotates. However, viewing the rotating frame from above, we see the same distortion, and now we can't attribute it to perspective. As the frame rotates, each corner moves away from the center, becoming increasingly acute. At its sharpest point, the corner reverses direction and moves back toward the center, becoming increasingly obtuse. This is not a visual trick. The frame continuously changes shape as it rotates. A machine that I'm designing requires this movement. Although the machine doesn't require the frame to have a particular shape, only a parallelogram can do it. The whole frame rotates around its center, but only the center of each side rotates in a circle. Each corner's trajectory is an ellipse. Two opposing sides pivot around axles projecting upward from the ends of the center bar. Because all four sides are joined by hinges at their corners, they pivot around their centers in unison, the attached sides around real axles and the other two around virtual axles. A rod connects one corner to a stationary point offset from the frame's center. Both ends of the rod can rotate at their attachment points, but the rod is otherwise inflexible. The corner is forced to rotate around the offset point, but it also oscillates around the centers of the adjacent sides, which are rotating around the frame center. These movements combine to move the corner through an elliptical path. As with the pivoting sides, the other three corners are forced to follow in unison, each rotating around its own virtual offset point. The overall effect is a rotating, undulating diamond. Despite its complexity, this movement is driven entirely by simply rotating the frame.